Section 11.1 sequences. I send you my notes. Whenever I send you notes, you might want to print them out and bring them to the class so that you can take your notes on that, because I won't be giving you enough time to write everything that I have written down. So sequences, what is a sequence? Well, the sequence is just a function. It is a function where the domain is just a set of positive integers. Okay, remember, this symbol n means the set of positive integers. This symbol r means the set of real numbers. So a sequence is just a function where the domain is a set of positive integers and the range is the set of real numbers. Actually, the range could be set of complex numbers as well, or many other things. But for our course, the range is the set of real numbers. Now, for example, if I look at f of n is equal to 2n, where n is greater than or equal to 1, then what is this function? Well, this function is, let's write down the first couple of values of this function. F of 1 would be 2, f of 2 would be 4, right? F of 3 would be 6, f of 4 would be 8, and so on, right? You agree? Because f of n is twice n. F of n is twice n. Now, when you have a sequence, we view that sequence as an infinite list. When you have a sequence, we view that function as an infinite list. So I have the first f of 1 is viewed as the first term of the list. F of 2 is the second term of the list, or f of 3 is the third term of the list, and so on. Is everybody okay? Now, when you have a sequence is just a special type of function, right? The domain is basically the set of integers. Now, when we speak about sequences, it is more traditional to denote a sequence by using the lowercase letters from the beginning of the alphabet, like A, B, C, D stuff, instead of using F, G, and H. Okay. So we are going to denote sequences by lowercase letters from the beginning of the alphabet. For example, A of n. A of n, let's say, is defined by n squared. N is larger than or equal to 1. So what are some of the values of this sequence? Well, what is A of 1? A of 1 is 1. A of 2 would be 4. A of 3 would be 9, and so on. Right? Is everybody clear? There is another tradition when we speak about sequences, and that tradition is that instead of writing A parentheses n, we write A subscript n. So the value of the function A at n is denoted by A subscript n. So, for example, in my previous example here we can write A1. A subscript 1 will denote A of 1, which is 1. A subscript here, A subscript 2, it would be A of 2, which would be 4. So instead of using parentheses to write the input, you write the input as an index. Is that okay? Write the input as an index. Okay, so that's a traditional notation people use in order to express a sequence. We may also express a sequence A of n by writing the formula for A of n, or the terms of the sequence A of n, within curly braces, and writing the valid values of n outside of the braces. Okay? Is everybody clear? Now, for example, let's look at the next sequence, AN. A subscript n is given by n divided by n plus 1, where n is larger than or equal to 1. Okay, so that's the sequence. Okay, and another notation for that sequence would be n over n plus 1, where n is bigger than or equal to 1. So outside the curly brackets, you write down the valid values of n. Now we can also say this is the same as half, 2/3, 3/4, 4/5. So instead I can just write down first couple of terms of the sequence and write ... meaning that the remaining terms can be found by using the pattern. So whatever the pattern is, follow that pattern to get the other values. Another example, let's look at root of n greater than or equal to 1. That sequence is basically the first few terms are 1, root of 2, root of 3, root of 4 is 2, and then root of 5, and so on. Once again, a sequence A subscript n, where n is larger than or equal to 1, may be viewed as an infinite list. A1, A2, A3, A4, ... We say that A1 is the first term of the sequence. We say that A2 is the second term of the sequence. We say that A3 is the third term of the sequence, and so on. Remember, sequence is a function. So what is A subscript 1? A subscript 1 is the value of the function at 1. A subscript 2, value of the function at 2. A subscript 3, value of the function at 3, and so on. And we call them the first, second, and third, and fourth terms. Now, suppose that I have an infinite list of numbers, b3, b4, b5, b6, and so on. So suppose I have a function, but the function is defined on integers larger or equal to 3. Okay, I have a function b that is defined for integers larger than or equal to 3. So b3, b4, b5, b6. Should I call that a sequence? So far, all our sequences started at 1, right? A1, A2, A3. Now I have a infinite list where the index starts at 3. Should I call that a sequence? And the answer is yes. I mean, what's the difference between starting at 1 or starting at 3? Okay. I should also call an infinite list like that a sequence as well. And so, for example, let's look at n divided by n plus 1, where n starts at 0. So what is this sequence? This sequence is 0, half, 2/3, and so on, right? So the index starts at 0. For the next example, I have e to the root of n plus 2. N is greater than or equal to negative 2. I can also start the index at a negative number if I want to. So what is the first term here? The first term is what? The first term is a subscript. The first term is a subscript negative 2, right? The first term is a subscript negative 2. I am calling that sequence an. So a subscript negative 2 is the first term of that sequence. Am I making sense? So I don't always have to start at 1. Okay? I can start at any integer I like. Okay? Now, given a sequence an where the starting index is n naught. So n naught is the starting index for the sequence. So what is the first term of this sequence? The first term of this sequence is this guy, right? This is the first term of that sequence. And I am going to say that this sequence starts at n0, or I'm going to say that n0 is the starting index or the starting point of this sequence. Am I making sense? I'm going to call n0 the starting index of the sequence or the starting point of the sequence, And also I might use the language, the sequence starts at n0. Now this is not a universal terminology. This is not a terminology used by any of the books, I think. Okay, this is just some language that I want to use in order to explain what I'm going to explain next. Okay, is everybody clear with what I'm saying? So in the next two examples, I'm going to say that the first sequence starts at 0, or I will say that the starting index of the sequence is 0. The second example, I'm going to say that the starting index or point is -2, or I'm going to say that the sequence starts at -2. Starts at index -2. Okay. So here's the remark, and I'm going to justify that remark in detail. The starting point of a sequence can be changed to any given number. The starting point of a sequence can be changed to any given number I like. Okay? Which means that really for a sequence, what is the starting index doesn't matter. It doesn't matter what the starting index is, because I can make the starting index whatever I want it to be. Am I making sense? Let's see how. Let's say I have a general sequence AN, and the starting index is 1. So I have A1, A2, A3, and so on. And the question is, can we change the definition of AN in such a way so that the starting index is 3 instead of 1? And still I have the same infinite list. Am I making sense? Instead of starting at 1, I want to start at 3, but I still want to have the same sequence. How is that possible? Well, it's quite possible. Let's think about the following. My sequence starts at 1, and I want to start at 3, which means that I want to go forward by 2 indices, right? I want my initial index to go forward by 2 indices, right? In order to achieve that, define the following sequence Bn, where Bn would be an minus 2. That is, whatever the formula for An is, replace n by n minus 2. Okay? If you do that, then your starting index would be 3. And still you'll have the same sequence. So here, Bn is An minus 2, and n is larger than 3. Again, how did I get to n minus 2? My sequence starts at 1, but I want to start at 2, which means I want to start 2 indices forward, right? 2 indices forward, then I'm going to subtract 2 from n. And if I do that, notice that I'm going to get the same sequence. Let's see. So now Bn is defined for n greater than or equal to 3. So what is the starting index for Bn? Starting index for Bn is 3. So what is B3, B4, B5, B6, and so on? Well, that's Bn, n greater than or equal to 3. But what is the Bn? Bn is the same as An minus 2, where n is greater than or equal to 3. Now notice, let's compute some of the values of An minus 2, where n is larger than 3. When n is 3, what do I get? A1. When n is 4, I get A2. When n is 5, I get A3. Which means the sequence B3, B4, B5, B6, and so on is the same as the sequence A1, A2, A3, and so on, right? Am I making sense? Similarly, I can also start my index. Here I started my index at 3, right? I can also start my index at -2. Okay? So how can I start my index at... sorry, I think I might have I want to start my index at -1, let's say. I want to start my index at -1. So how would I do that? Well, if I want to start, right now my sequence starts at 1 again, and I want to start the sequence at negative 1. So that means two indices backward, right? Then what should I do? Well, I should replace n by n plus 2. Okay, if I want to start 3 indices backward, then I have to replace n by n plus 3. Okay, so in this case we are going to replace n by n plus 3. So I'm going to define Cn to be an plus 2. N is larger than or equal to negative 1. And notice that the sequence Cn starts at negative 1, but the sequence Cn is the same as the sequence an plus 2, right? It starts at negative 1. But if you look at the first few terms of this sequence, what do you get? Well, when n is negative 1, you get negative 1 plus 2, which is a1. When n is 0, you get a2. When n is 1, you get a3, and so on, which is exactly the same as the original sequence an, starting at 1, right? Am I making sense? So it is possible to start your sequence anywhere you want. Let's look at another example. This time let's take a specific sequence. Let's say I have the sequence an given by root of n minus 2. N is larger than 2. So what is the starting index for this sequence? Starting index is 2, a2. Right? So what is a2? 0, a3 is 1, a4 is root 2, a5 is root 3, and so on. If I don't change the definition of this sequence, can I start the sequence at 1? Notice that the sequence is undefined at 1, right? Unless I change the formula, if I use the same formula when n is 1, it's undefined, right? So the way the formula is, I cannot start at 1, right? Now, let's suppose that I want the starting index to be 5 instead of 2. I want the starting index to be 5 instead of 2. How would I do it? Well, what is my desired index? What is my desired index? 5. What is my given index? 2. 5 minus 2 is what? 3. That means I want to go forward by 3 indices, right? I want to start 3 indices forward. Then I'm going to replace n by n minus that 5 minus 2. N minus 5 minus 2, that is n minus 3. So if I replace n by n minus 3, what do I get? Let me define Bn. Bn is an minus 3. I am replacing n by n minus 3. So remember the definition of an? Definition of an was root of n minus 2, right? That was the definition of an. I'm replacing n by n minus 3. If I do that, I get exactly root of n minus 5, right? So replace n by n minus 3, you get root of n minus 5, and then the starting index will become 5. Okay, yeah.
If you want to go from 2 to 5, you subtract 3.
Yes. So because you're trying to start 3 indices forward, you have to subtract. If you want to start 3 indices from backward, then you add.
So if you go 5 to 3,
yes. We're going to see an example in a second. So what is B5? B5 is 0, B6 is 1, B7 is root 2, B8 is root 3, and those are exactly the same values of the original sequence, right? So you look at the sequence B starting at 5, and look at the sequence A starting at 2. They have the same terms, right? Same infinite list. Okay. All I did is actually, the sequences are the same. All I did is change the initial index. Now let's suppose that I have the same problem where an is root of n minus 2, n is larger than or equal to 2, but this time let's say I want my starting index to be 0. If I want my starting index to be 0, then what should I do? Well, what is my desired index then? Desired index is 0, given index is 2, What is desired index minus the given index? 0 minus 2, that's negative 2. Subtract that from n, what do you get? Did that make sense? My desired index is 0, given index is 2, subtract, you get minus 2, subtract that from n, you get n plus 2. So if you want to start at 0, that means you are going backward by 2 indices, right? In that case, you add to n. So now you're going to replace n by n plus 2. If I replace n by n plus 2, in the definition of an, I am going to get root of n, right? So then then the sequence starts at 0. Is that making sense? Is that okay? Is everybody okay with what I just said? So the sequence root n greater than or equal to 0, is the same as the sequence root of n minus 2, where n is greater than or equal to 2. Okay? There is no difference between these two sequences. They are the same sequences. Right? Is that okay? Let's look at one more example, and then this time let's make sure everybody gets it. Let's say I have the sequence an, which is 1 over n. N is larger than or equal to 1. So my given starting index is 1. Now I want to start my sequence at the index 3. So what should I do? What should I do? Subtract. So your given index is 1, but you want to start at 3. That means you want to go forward by 2 places. In that case, you replace n by n minus 2. Right? So you go 1 over n minus 2. And if you look at the sequence an and bn, they are exactly the same sequence. Right? Next, let's say I want to start my index at negative 4. If I want to start at negative 4, but my given index is 2, that means I'm going backward. Sorry, my given index is 1, so I'm going backward by how many indices? 1, and then 0, negative 1, negative 2, negative 3, negative 4. 5 indices backward, right? So I'm going to replace n by what? N plus 5, because I'm going backward. And I'm starting at negative 4. So what is B1, for example? A1 is 1, B1 is 1, C1 is also 1, right? And you can see that A2, B2, C2, they are the same. A3, B3, C3, they are the same. So all these sequences A and B and C are the same. All I did is change the beginning index. Right? It is very useful to change the index in many problems sometimes. Alright, so if you're okay with that, changing index of a sequence, changing the initial index of a sequence, let's look at the following. This is a very important sequence. Negative 1 to the n. Very simple sequence, but very important. Negative 1 to the n is larger than or equal to 1. What are the terms? Well, when n is 1, the first term would be what? Negative 1. The second term would be positive 1. The third term would be negative 1, and so on. So you are getting alternatively 1 and negative 1, right? Now, the next sequence is negative 1 to the n plus 1. However, I'm starting at the same index, 1. The initial index is the same, but I changed the exponent or negative 1. So what's the effect of that? What's the effect of that? Well, when n is 1, what is negative 1 to the n plus 1? Negative 1 to the 2 when n is 1, so you get positive 1. So now, the first term of the sequence is positive 1, and then you get negative 1, positive 1, negative 1, positive 1, and so on, right? So what's the difference between the two? Well, the first one starts at negative 1 and then alternates the sign. The second one starts at positive 1 and then alternates sign, right? Am I making sense? Okay, so let's now think about the following question. Let's say I have a sequence. Let's say I have a sequence which is n. And let's say n is greater than or equal to 1. What is this sequence? It's just 1, 2, 3, 4. That's the boarding sequence. 1, 2, 3, 4, 5, 6, and so on, right? This is the sequence of positive integers, right? If I just have n greater than or equal to 1, it's just the sequence 1, 2, 3, 4, and so on. Now, let's say I want to I want to have the same sequence n. However, I want to start with a positive term. I want the first term to be positive, and then I want the signs to alternate. So what should I do? Did my question make sense? So you want to multiply by negative 1 to the what? N plus 1. Because if you multiply by negative 1 to the n plus 1, then the first term would be positive 1, and then the second term would be negative 2, right? The third term would be positive 3. The fourth term would be negative 4, and so on, right? Now let's say I want to start I want the first term to be negative and then alternate. Well, then it's obviously what? Negative 1 to the n. So if I multiply by negative 1 to the n greater than or equal to 1, then the first term is negative, and then the signs alternate, right? So the first term would be negative 1, second one would be positive 2, negative 3, positive 4, negative 5, positive 6, and so on. Is everybody okay? All right, so let's look at the next example. Now, this example, you are given a sequence, and you're given the first few terms of the sequence. You are to recognize the pattern and write down the formula for the nth term of the sequence. Is that clear? You're given the first few terms, you have to write down the nth term. How? Well, let's write down A1. What is A1? A1 would be half, A2 would be 2/3, A3 would be 3/4, A4 would be 4/5, and I want to write down AN, right? The nth term. Well, what's the pattern here? And what's the relationship between the terms and the indices? Right? The indices are 1, 2, 3, 4 here, right? What's the relationship between the index and the term itself? The value of the term. Well, notice the numerators are just increasing, right? 1, 2, 3, 4, right? The denominator starts at 2 and then increases, right? What's the relationship between the index and the numerator? What's the relationship between the index and the numerator? They are equal. What's the relationship between the index and the denominator? One more, right? So I get what? AN should be, the numerator should be n, the denominator should be n plus 1, and then n is larger or equal to 1. Is everybody okay? Okay, so let's look at the second. In the second problem, you're given the sequence negative 2/3, positive 3/9, negative 4/27, positive 5/81, ... The first thing you want to recognize is that the signs are alternating, right? And the signs are alternating, but the first sign is what? So how can I take care of that? I can write negative 1 to the n. Remember, I'm going to take n to be greater than or equal to 1. So then the first term would be negative, and then the signs will alternate. Okay, let's look at A1. A1 is negative 2/3. That's the same as negative 2/3 to the power 1. A2 is 3/9. That's 3/3 squared. A3 is negative 4/27. That's the same as negative 4/3 cubed. A4 is 5/81. That's the same as 5/3 to the 4. Okay, let's now look at the relationship between the index and the numerator and the denominator. What's the relationship between the index and the numerator? One more. Right? Whatever the index is, the numerator is one more. And what's the relationship between the index and the denominator? The denominator is always a power of 3. So what's the exponent on 3? Whatever the index is, the exponent on 3 is the same. Right? So what do I get? I get that the numerator would be 1 more than the index, right? And the denominator is 3 to the power, what? N. And I'm done. Is everybody okay with that? All right. Let's look at the next sequence, cosine of n pi over 2, n larger than or equal to 0. All I want to know in this problem is what are the terms. So what's the first term? When n is 0, what is that? Cosine 0 is what? 1. When n is 1, what do you get? Cosine of pi over 2 would be 0. When n is 2, cosine of pi, negative 1. When n is 3, 0. What do you get after that? 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 So what's happening here? So this pattern 1 0 minus 1 0, that's repeating. 1 0 minus 1 0, that's repeating. Okay? Everybody's okay? So I actually know exactly all the terms of this sequence. All right. We can look at the graph of a sequence to get some intuition about the sequence. Suppose that, so what's the graph of a sequence? Well, a sequence is, after all, is a function, right? So if it is a function, it has a graph. But when you have a sequence, there are two ways of visualizing the sequence. One is the usual graph. That is, as a function, I look at an horizontal axis, I'm going to put the input values, and the vertical axis, I'm going to put the values of the sequence. So when n is 1, the height of the point at 1 would be a1. What is a1? a1 is half. a1 is half. What is a2? a2 is 2/3. a3 is 3/4. a4 is 4/5, and so on. So the graph of a sequence is just a bunch of dots, right? Is everybody okay? Now there is another way of visualizing a sequence. What is that? Well, just write down the real number line, and on that just plot the terms. So a1 is half, right? a2 would be 2/3, a3 would be 3/4, and so on. So you're just plotting the terms here, right? You're plotting the terms. You're not plotting the inputs. Here you have the inputs on the horizontal axis, the terms on the vertical axis. Here you're just plotting the terms. Am I making sense? Now from the pictures, it seems like our sequence n over n plus 1 is getting closer and closer to 1. Right? And we can express that by saying that the limit as n goes to infinity of n over n plus 1 is 1. Okay? Is everybody okay with that? Any questions? Now, we have seen limits before, but this is in the context of a sequence that we are looking at it, but it's very similar. However, I'm just going to assume that we don't know anything about limits at this point. And I'm going to define what do we mean by a limit one more time for a sequence, okay? So when we have a sequence, there is only one type of limit. Remember, for a function, I look at the limit of the function as x goes to 2, 3, 5, half, negative infinity, positive infinity, from the left, from the right, right? For a sequence, there is only one kind of sequence. What is that? What happens when n goes to infinity? There's only one type of sequence. What happens when n goes to infinity, when the index goes to infinity. What's the limit of the sequence? And in this case, we are saying that the limit should be 1. So let me try to explain what does it mean to say that the limit of a sequence is 1. First of all, in this case, when I say that the limit of the sequence n over n plus 1 is 1, what do I really mean? Well, very loosely speaking, I mean that the sequence is getting closer and closer to 1 as n gets bigger and bigger. But that's very informal way of saying it, because you can ask, hey, how close does it get to 1, right? The value of the sequence will never be 1, right? Because the numerator is strictly less than the denominator, right? So how close does the sequence get to 1, right? I have to explain that as well, make it more formal. So in this case, I'm going to say, well, let's look at the difference between 1 and the sequence. So 1 is the limit. I'm claiming 1 is the limit. If I look at the difference between 1 and n plus 1, what is that? Well, if you do some algebra, is it n plus 1 minus n divided by n plus 1? And what is that equal to? 1 over n plus 1. N plus 1 is positive, so I don't need the absolute value sign. Okay. Now, what does it mean? It means that if I look at the let me call an to be n over n plus 1. So what did we do? We are saying here that 1 minus an, the difference between 1 and an, is equal to 1 over n plus 1. Right? So I can see that as n gets bigger and bigger, the difference is becoming smaller and smaller, right? As n gets bigger and bigger, the right-hand side goes to 0. Therefore, the difference between 1 and an goes to 0, which means that an is getting closer and closer to 1, right? Am I making sense? 1 over n plus 1, as n gets bigger and bigger, 1 over n plus 1 is getting smaller and smaller and getting closer and closer to 0. Therefore, the difference between 1 and an is getting closer and closer to 0, which means that an is getting closer and closer to 1. But more precisely, I want to say, how close does it get to 1? How close? And the answer is as close as you desire. Okay? So what does it mean? It means that let's say I want, give me a number, like let's say I want the difference between 1 and an. Let's say someone in the class tells me that can I make an within, let's say, 0.001. Can I make an within 0.001 of 1? Right? That means, can I have that? Can I have the difference to be less than 0.001? Can I accomplish that? And can I accomplish that? Can I accomplish that for all n after some point? Can I accomplish this? Can I make the difference smaller than any given small number you give me? Right? For all n after some point on, right? After some point on, all the terms will have to satisfy this. Is that making sense? Now, can I accomplish that? Do you think I can? Well, I can, because if you look at this, if you trust this equation, right? Notice that I can say that this is less than what? If I take n bigger than 1,000, very good. If I take n bigger than 1,000, then I see that this is less than 0.001. Right? So for any n after 1,000, every single term is within 0.001 of 1. Right? Am I making sense? This is a more precise way of saying how close can I make it to 1. I can make the sequence as close to 1 as I want to. So instead of 0.001, maybe one of you is more ambitious and say, well, I am going to write 0, 0, 0, dot, dot. Let me put dot, dot here. I'm going to write 0 for the rest of my life, every single second until I die. And can you make an within that number? Okay, the answer is, of course, I can make an within that small distance from 1 simply by picking n larger than what? Well, if you want to make it close to within 0.0001, instead of picking 1,000, you're going to pick what? 10,000, right? You want to put another 0? Put another 0 after the 10,000, right? And so on. Is everybody clear? Yes. Yeah, we're going to get there. We're going to get there. How to compute the limits. Right now, I'm just explaining what is the meaning of the limit. What is the meaning of the limit? Because you may not think that there is much here, but there is a lot here. Because what we are saying is that I can make an within any small number of 1 after some point on. So after some point on, any term of the sequence is within 0.001 of 1. Now 0.001 of 001 could be any small number. Okay? So in other words, if I in the real number line, if I look at the limit 1, what we are saying that somebody give me any small number epsilon you can imagine in your head, and give me a very, very small interval centered around 1, okay, can I make every term of the sequence an to lie within epsilon of 1 after some point on? Can I make every term of the sequence after some point on to lie within that interval? If I can, it means that the limit is 1. Am I making sense? When I say that the limit of the sequence is 1, it means that no matter how small interval you give me around 1, I can always go far enough along the sequence so that after some point on, every single term is in that small interval around 1. Okay? And that sort of takes care of the question, how close does the sequence get to 1? Okay? Well, it gets to 1 as close as you want. Okay? You can specify how close you want it to 1 by specifying epsilon. And what did we say? We said that if we pick epsilon to be 0.001 in our problem, then we have to pick capital N 1,000. That is, after the first 1,000 terms, every single term after that will be within 0.001 of 1. And that's what the limit means. In any case, let me now write down formally what is the definition of the limit as n goes to infinity of an is L. Here, L represents a real number. The limit of an is L means that an can be made as close to L as desired simply by choosing any n larger than a suitably large integer n. Okay? So, and once again, it means that if the L is the limit, it means that give me any small interval around L, then I can go through the sequence. I can go far enough along the sequence so that after some point on, every single term will be in that interval. Okay. If the limit exists as a number, then we say that the sequence is convergent. We say that the sequence is convergent if the limit is a number, or we say that the sequence converges to L. On the other hand, if the limit doesn't exist as a number, then we say that the sequence is divergent. Okay? Is everybody okay? Now, if the limit of the sequence is infinity, then we say that the sequence diverges to infinity. If the limit of the sequence is negative infinity, then we say that the sequence diverges to negative infinity. But we are going to call it convergent only when the limit is a number. Graphically, what is the meaning of a limit? Well, if you look at the graph of the sequence and look at the horizontal line at the limit L, it means that the graph of the sequence is getting closer and closer to the horizontal line at L. Okay? So graphically, the meaning of the limit L is this. Okay? More precisely, if you look at the graph, look at the limit L, and look at, let's say epsilon is a very tiny number. Look at L minus epsilon and L plus epsilon. So the green lines are horizontal lines at L plus epsilon, L minus epsilon, where epsilon is a very tiny number. Then the limit is L means that if you, after some point on, after some point on, the graph of the sequence will be within epsilon of L. After some point on, the graph of the sequence will be within epsilon of L. Okay? Is everybody okay with what we just did? That's the meaning of the sequence. That's the meaning of the limit. However, we are not going to use the definition to compute limits, of course. Let's make life a little bit easier. How do I compute this limit here? To compute this limit, first of all, I'm going to do it without using the L'Hopital's rule. Okay? So here, I'm going to say that I'm going to talk about how to use L'Hopital's rule for a sequence. In this case, you just factor out the highest order term. If you factor out the highest order term, you get this. And then you can cancel out the highest order terms. And then as n goes to infinity, this guy goes to 0, this guy goes to 0, then you're left with 1/3. Okay? All right, so I'm going to start from there.